या मैं क्यों इनको जीना नहीं, विक्टिम कार्ड प्ले करके खून पीना सही। हाँ इनमें फर्क नहीं, इनका गलत भी सही, तभी तो इनकी अपनों से भी बनती नहीं। रीच 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 इनको चाहिए रीच, प्लीज 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 सामने करते प्लीज। बीट 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 इनको करूंगा बीट, हीट 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 मेरा कंटेंट है हीट। मैंने ही मिटानी ये बीमारी, मैंने ही तो जानी ये बेमानी, मैंने ही मिटानी भ्रष्टाचारी, मैंने ही संभाली जिम्मेदारी। सांपों से भरा है पूरा ये समुंदर, पीठ पीछे मारा है इन्होंने खंजर। इनसे हम सब लड़ेंगे अब मिलकर, इनकी जिंदगी अब बनेगी बंजर। लेट्स गो। एक कहानी है जो सबको सुनानी है, चलने वालों की तो रूह भी जलानी है। एक कहानी है जो सबको सुनानी है, इनकी भूख भी तो मैंने ही मिटानी है। एक कहानी है जो सबको सुनानी है, चलने वालों की तो रूह भी जलानी है। एक कहानी है जो सबको सुनानी है, इनकी भूख भी तो मैंने ही मिटानी है।
So we have written it is an opposing force developed between two solid layers in contact when they are in impending motion or they are in relative motion. That means sliding one over another. Okay. Next, friction is caused due to intermolecular forces of surfaces in contact. We have written that line also.
Yes, sir.
Isn't it?
Yes, sir.
Now continue. Static friction. Static friction. It is a friction developed between two solid layers. It is a friction developed between two solid layers when it is under impending motion. When it is under impending motion. When it is under impending motion.
Sir, sorry to interrupt. Impending motion is force applied but insufficient to cause motion, right?
Insufficient, yeah. It has a tendency to move, but it's not moving.
Oh, thank you, sir.
Next para. Static friction is self-adjusting. Static friction is self-adjusting. Static friction is self-adjusting. As the applied force increases, static force increases. Static friction also increases. As applied force increases, static friction also increases. I told you the reason. Because that bond, how much it's strong, if you keep on exerting the force, bond also will increase the force until it breaks. Once it breaks, it starts moving. Once it starts moving, intermolecular force of attraction will reduce. So we have to apply only less force for it to move. So that maximum value that friction goes when it is at rest. That static state of rest. That's called static friction. Is it clear? Static friction is self-adjusting. As the applied force increases, static friction also increases. And then it attains a maximum value. Then it attains a maximum value. Bracket FSM, static friction maximum value. That's the meaning of it. FSM. This maximum value of static friction is known as limiting friction. This maximum value of static friction is known as limiting friction. This maximum value of static friction is known as limiting friction. Okay, next, laws of static friction. Laws, L-A-W-S, laws of static friction. Laws of static friction. This experiment, actually you will do it in the school. This is an experimental setup. This is a wooden board, and over that you will be provided by some weights. See, like this one, weight will be provided to you. A wooden block. or any solid material you can use there. Okay. Now we are going to study the maximum value of static friction between these two surfaces. That's our experimental aim. Here in that arrangement, a string is connected here. A string is connected. At the end of here, a pulley is connected. A pulley. You heard about pulley, right? P-U-L-L-Y. L-L-E-Y.
Yes,
and here over this string will come down. And from here straight away it will go down here. At this point there is a weighing pan. Weighing this one. A pan. You can fix something in here. So here put 100 gram initially in the laboratory. 100 gram means 100 gram means 0.1 kilogram into 9.8. Approximately, we are taking 10 for calculation easier, to make it easier. So this is 1 Newton. That means 100 gram when you are placing here, you are exerting 1 Newton force here. Now we know object may not move here. If it is not moving, then you will just knock down there. Check whether that joint's broken or not. If joint's broken, we imparted a velocity into it. So with that velocity, it will start moving with a constant velocity. So that purpose only, each time when you're loading here, you have to just knock on near the block. Knock here on this. Just give a jerk. If it is not moving, that means again friction can increase. So at this particular stage, assume that a friction developed here. That friction is static friction, okay, here. This value now we can say it is Fs, static friction, that is 1 Newton. Now I am making it loading 2 Newton. Suppose again it is not moving. So I just check whether that joint broken, just knock it over that. If it is moving, then stop. That is the maximum value. If it's not moving, again it can increase. That is the meaning of it. So at this particular stage, static friction value is 2 Newton. At this particular stage, value of static friction is 2 Newton. Again, I'm loading 3 Newton. When I reach 3 Newton, when I knocked, it just start moving with a constant speed. That means static friction is not going to increase anymore. So that value of static friction we call maximum value of static friction. Here, the weight of this body is say 1 kilogram, for example, 1 kilogram. Now the weight acting downward here is 1 into 10. That means 10 Newton. 10 Newton. Suppose I'm replacing this 1 kilogram by 2 kilogram, or I'm placing one more body above this. So it will come 2 kilogram total.
20 Newton.
Then do you expect at 3 Newton this will move?
No, sir.
No, because when weight is increasing, that bond become more stronger. Isn't it?
Yes, sir.
When weight is increasing, that you become more pressed to each other. Molecules go more closer. Then bond become more stronger. So you have to apply, you have to put here more force, say 4 Newton or 5 Newton or 6 Newton, for example. Because weight doubled here, you can see almost 6 Newton when you are putting here, you can see this will start moving. That means maximum value now changed to 6 Newton. Until then, static friction will increase. So it means the maximum value of static friction is directly proportional to weight of this object. But the thing is, even though weight of this object we know, but I am not marking here mg. Instead, I am going to mark a term which is called reaction. What is this normal reaction? Why not I am marking mg? This is what first you have to understand here. Okay, look here. Suppose this is a surface. Here we are placing an object. Its weight is 1 kilogram. Now mass is 1 kilogram. Now weight acting downward is 10 Newton. This is a tabletop. Here, tabletop is not breaking down and this object is not going down because tabletop gives an equivalent opposite force upward. This is Newton's third law, isn't it? So here, same 10 Newton develop. So net force becomes 0. If I'm making it 2 kilogram, this becomes 20 Newton. Then reaction also will increase to 20 Newton. So how much force you are exerting onto the floor, that much only reaction come. Suppose you have a 2 kilo body in your hand and you are tying a string over that. Body may be 2 kilogram, but you are giving a lifting effect. So that 2 kilogram is not exactly pressing onto the floor. So it is not just the mass that decides the force acting onto the floor. You must think whether it is acting or not. For example, I'm tying a string here on the top, okay, and here it is just touching the floor. That means 2 kilogram is there touching, but we are giving an upward force. So action onto the floor is not that high. Freely if you are placing, we can say completely it is pressed. So reaction does not mean directly we can take mg. You should make sure that this mg is completely acting onto the floor. For example, same surface I am keeping this way. See, like this I am keeping. An inclined plane I am keeping here. And same 1 kilogram body I am placing here. Now, action means which is exerting onto the floor, and that only goes as a reaction. But here the problem, weight always acting downward. This pen, if I'm keeping, weight will be acting from center of gravity downward. If I'm keeping, weight will be acting downward. If I'm keeping like this also, weight will be acting downward. That means this mg will be acting downward. Now you see, mg is not completely acting onto the floor. This theta and here how much this is tilted, that theta and this theta are equal now. Now we can divide this one. This is theta. This we can divide into, this will be mg cos theta. This is opposite side of theta. That is mg sin theta. Now the force acting onto the floor is mg cos theta, not mg. If this angle is 60 degree, for example, here you place 1 kilogram. Here 1 kilogram when you place, you got action 10 Newton, reaction 10 Newton. But in this case, if 60, 10 into cos 60 will come. That means half. 5 Newton only acting onto the floor. So reaction also 5 Newton. So bond between molecules of here become half strong. That strength will be reduced. That means friction is reduced. So it has more tendency to slide. That's what here we are more safe. But here it is easily sliding down. So a heavy object, instead of pushing through the horizontal floor, from the top floor, if you want to bring, you keep a slide and keep here, you can see it easily comes down. Because that weight factor now divided into 2. One component mg sin theta pulls the body down, mg cos theta acting onto the floor, providing action and reaction. This reaction only deciding how strongly they are producing a bond between the molecules. Did you understand?
Yes, sir.
So in the normal case, we can say this mg is equal to reaction. But it does not mean every time mg is not reaction. Out of mg, in this case, only mg cos theta, only a small portion only acting onto the floor, that only developing as reaction. So we cannot say mg's are always.
Sir, can we say that heavier objects have stronger bonds?
Yes.
Okay, sir.
I'm talking about same body, we are keeping at different angles. You understood?
Yes, sir.
Same 1 kilogram body, I am keeping at different angles, will have a different force exerting onto the floor. Did you understand that?
Yes, yes.
So what is the difference between a grip and the friction?
What?
Yes, we will say that the grip was not good, so we lost it. It is slippery, it's not grippy. Grip.
I did not hear you. Once again.
What is the basic difference between a grip and the friction?
Both are same. More grip means more friction develop. That's all. Okay. So again, I'm repeating. Say a body here, I'm keeping it. 1 kilogram body, I'm keeping here, for example. Okay, exactly horizontal. And this is a 1 kilo body. 1 kilo body. So here, action, that is mg, and reaction also mg in this case, because mg is not splitting. So mg is equal to here 10 Newton, reaction also 10 Newton. So this 10 Newton produces bonds here. That decides how stronger the bond. But same plane I am keeping tilted now, this way, okay, at an angle 30 degree. Now object is like this now. Object now tilted. Same 1 kilo body now in this place. Now here weight is still acting downward. There's a weight. Okay, normal is this. Normal to the surface is this. This is the normal. Normal means perpendicular to the surface. So here mg is still acting 10 Newton. Now if this is 30 degree, this angle also will be 30 degree. Then this will be mg cos 30. And this side will be mg sin 30. So here now mg cos theta only acting as r. Now mg cos theta 10 into what is cos 30? 1 by root 2, right?
1 by root 3.
1 by root 2.
1 by root 2.
So that means around 10 by 1.414. This much force only now we are getting here, action. Now friction reduced that much. If I'm making the same surface tilted 60 degree. Look here, same surface tilted 60 degree. Okay, now again this angle increasing 60, this also increasing 60. Now mg cos 60. Now only 5 Newton acting onto the floor, reaction is 5 Newton. That means on the floor, now effect of action is reduced half. Reduced to half the value, 10 become 5. So friction also reduced to half. So easily it will come down. 90 degree if you are keeping the surface, then you see completely mg cos 90. That means no friction at all. No force acting onto the surface. It's just falling down. That's the meaning of it. That's what I am now telling. This one is directly, friction is directly proportional to mg. We are not telling here because mg is not always action. In a tilted planes, mg cos theta is action. So how much action you are giving, that decides reaction. How much strongly you press onto the floor, that much only reaction come. And this pressing only forming bond, that leads to friction. So very easily we can say, instead of mg, we can say r. This is more justified statement. Is it clear?
But sir, I have a doubt. Sir, if the surface is tilted, if you want to take the object to the upper side, we must have double force, right?
No, equivalent opposite force if you want to move it without acceleration. Mg sin theta you have to apply.
No, sir, like if the object is tilted and we have to take the object to up, like.
I'll show you. This is, for example, object. This angle is 60 degree. Weight 100 Newton. Now onto the floor we are getting only 50 Newton. But here mg sin theta, mg sin 60. Okay, that means 100 into sin 60 means root 3 by 2. 50 root 3. This much force you have to exert opposite. Then you can move it upward. Clear?
Yes.
Yes, sir.
Write down now. Laws of static friction. So draw this diagram, then easy for you to remember this idea. mg, this is reaction. This is applied force. Force you are applying, okay? Applied force. This is a friction developing.
FSM.
FSM. So here we can say the maximum value of static friction is directly proportional to this R. I'm not taking mg. I told you different situation. Mg cannot be taken as the action. Mg cos theta will be action in an inclined plane. So we have to develop a general formula here. That's what I'm writing R. That means how much force you're pressing onto the floor, that only reaction come. And this pressing only causing intermolecular force. More the press, more stronger bond develop. So friction will increase in that
So
case.
the material of the surface will be is required or not? Means we will-
What?
Does the material of the surface also matters or not?
Oh yeah, nature of the surface of matters very clearly. Nature of the material matters.
Like an object of same weight will keep in the glass and will keep on the road.
Different
Does
friction
the
will come.
friction will matter?
Different friction will come, yes. Suppose this 1 kilo we are placing on a wood. Okay, so here you have to apply just a 10 Newton force. But same object you are placing on a glass, you have to apply maybe 2 Newton force.
Okay, sir.
Isn't it? That depends on nature of surface also.
Yes, sir.
Write down. Laws of friction. The maximum value of static friction, bracket you write FSM, maximum value of static friction, is directly proportional to the normal reaction R. Is directly proportional to normal reaction R. Some books they are giving the symbol N. Normal reaction R. Mathematically, right here, FSM is proportional to R. And FSM divided by R is equal to a constant S called coefficient of static friction. Coefficient of static friction. Coefficient of static friction.
So what is that? FSM divided by R equals?
Mu S, mu S, coefficient of static friction.
That's new.
Mu. And another thing, if this object whether keeping like this and same object keeping like this, static friction value will not change. That remains same. Okay, right now. So FSM is independent. FSM is independent of the area in contact. Area in contact means which side doesn't matter. FSM is independent of area in contact, provided normal reaction remains same. Provided normal reaction remains same.
So independent of?
Area in contact, provided normal reaction remains same. So for example, an object, this side is 10 centimeter, this side 5 centimeter. If I'm keeping this way also, static friction, to move it, same force you have to exert. Independent of area in contact, provided.
Sir, but
normal
bonds will
reaction
be more,
same.
right?
Provided.
Sir, bonds formed will be different, right? So it would take more time.
Same thing. See, if there are 4 points in contact, suppose 100 Newton force. If 4 points in contact, it will divide to 25, 25, 25. If 2 points in contact, that will divide to 50, 50. So each point bond is double strong. Isn't it?
Yes, sir.
So it won't make a difference. If area is more places bond will come, but weaker one. If area is less, same weight should exert, but bond will become stronger accordingly.
Provided.
That's what we have said, normal reaction, provided normal reaction same. Next, numerical. A block of 2 kilogram. A block of 2 kilogram. A block of 2 kilogram is placed a block of 2 kilograms is placed on the floor of coefficient of static friction, mu s, of coefficient of static friction is 0.4. Coefficient of static friction is 0.4. A force of 2.5 Newton, a force of 2.5 Newton is applied. A force of 2.5 Newton is applied onto the block. A force of 2.5 Newton is applied onto the block. Calculate the friction between the block and the floor. Calculate friction between the block and the floor. Okay, look here. See, we can say usually static friction is self-adjusting, but until a maximum value of limiting friction. That means if you are exerting here 1 Newton, static friction will become 1. If you are exerting 2 Newton, this will be 2. If this is 3 Newton, this will be 3. But if limiting friction is 3, if you are exerting here 5 Newton, this friction cannot be 5 Newton. It cannot exceed more than 3. Now the question in this setup, 2.5 Newton I am exerting, coefficient of static friction given, what is the friction developed? So first of all, you must make sure that this value applied is less than maximum value of limiting friction. Then only we can do this numerical. So first I am going to calculate that. FSM is equal to mu s into R.
Static friction.
Mu s is equal to 0.4. Reaction, this is 20 Newton. This is also 20 Newton. Okay, reaction 20 Newton because it's a horizontal surface. So answer will be how much? 8 Newton, right?
Yes.
So until 8 Newton, suppose you are giving here 1 Newton, this is 1 Newton. This is 2 Newton, this is 2 Newton. This is 5 Newton, this is 5 Newton. This is 8 Newton, this is 8 Newton. But if this is 10 Newton, this will not increase, this stopped. Object will start moving with an acceleration. Now, we are applying 2.5 only. Okay, we are applying 2.5. That means friction also should be 2.5 because it is self-adjusting until 8 Newton. Is it clear?
Yes.
So sir, at exactly 8 Newton, will the object move or will it stay still? At exactly 8 Newton.
At 8 Newton, it can be at rest or it can move. It's up to you. That's what I told you. Each time when you load, you knock it. When you put 8 Newton, suppose just joints broke. Molecular force stops. Okay, that point. Now, applied force and friction are equal. Net force is 0. It is at rest. If you knock, you make it in motion. After that, the force you gave, once it's in motion, suppose you gain a velocity of 1 meter per second. After that, you are knocking. You are not knocking. But now body is in motion, but forces are equal. That body will travel with a constant velocity.
Yes, sir.
At the time of limiting friction, it may be at rest, it may be in motion. That depends on you. You decide. That's why I told you an example. Look here. This is a pulley. Here you put 100 Newton force. Here you put 100 Newton weight. It will remain same. It won't move. But if you just give it a push, and that push, give it a velocity, it move up with a velocity 1 meter per second. Now it's in motion, but again forces are equal. You can see this will go with a constant velocity 1 meter per second. Again, if you give an opposing force 1 Newton here, it will stop. So in these cases, forces are equal and opposite. Now you decide whether it to be in motion or whether it is in rest. Is it clear?
Yes.